Welcome. The purpose of this video is to illustrate a general structure for writing a good paper that can be accepted in a peer-reviewed journals. The title of the paper, as you can see here, it is belong to mechanical engineering, and the paper topics on the heat transfer, especially on the topic of the heat exchanger, so that you can see that the title of the paper is Numerical Study of Shell and Tube Heat Exchanger with different cross-section tubes and combined tubes. As you can see, the first page of the paper contains generally the title of the journals, the check for update if there is an update. There is also the DOI for the paper, and here this is original research paper because there is original research paper and there is article research paper, and then there is the title, the authors that contributed to write the whole paper. Here you can see that the journals uh, generally add the time of receive the submission and the time of acceptance for this manuscript. You can see here that the authors submitted the paper on December 2018, and the paper had been accepted on February of 2019. Okay, after the title of the paper and the authors, there are the abstract of the paper. However, there are some journals added the affiliation of the authors belong their names. However, this is one of Springer journal. They add the affiliation of the authors on this region. This is the email of the corresponding author, which is his location as the second authors. Okay, now after this introduction on the title of the paper and the authors, there is the abstract. The abstract, okay, there is some journals actually require limited number of words on the abstract. For example, it should be not exceeded 200 words, sometimes 150, sometimes even more. Okay, generally the abstract should contain numbers, okay, values. The abstract should be start as a background about the paper, okay, about the problem, and then the materials and method that the authors used it to investigate and solve it, and then the major results should be added. Okay, also there is a keywords. Keywords is so important actually in the submission system for Elsevier or Springer or Taylor and Francis, Wiley, and a lot of publishers. They they want from the corresponding author to add the keywords, okay, on the submission system, not only on the paper files. This will help the editors to know the paper topic, and then they can suggest the reviewer easily, so that the keywords is so important on the paper. After that, there is the introduction. The introduction should be start by a general information about the paper topics. As we said, this is a paper focusing on the shell and tube heat exchanger. The authors try to study the influence of different cross-section tubes and combined cycle, as I will illustrate it soon. It generally, the introduction starts by a general introduction about the shell and tube, for example, about the problem of the paper, and then it gives the application for this problem, okay, as you can see here. Okay, for example, there is application of shell and tube heat exchanger and the refrigeration system, power plants, and so many other applications. So that it is important to cite the reference that support what the authors claim. Okay. After this small introduction, it should be, of course, attractive because generally the editors of the journals take attention for the abstract and the introduction. Okay, so that if the editor see the paper or the manuscript is attractive, then he can move forward and send it to the reviewers. But if he had some mm, comments or some body view from the first look on the paper, abstract and the introduction, he even never send it to the review and give it a disk rejection. Now, after this introduction, the authors start to describe the previous studies so that you can see here that the authors start to summarize the related works to their work. Okay, and after the introduction is completed, the authors generally add what they planning to study on their paper, which is will be on the material and method or methodology, so that you can see that the author's material and methods is subdivided into a geometrical model. You can see here that this is the geometrical model. You can see it is better to draw the shell and tube heat exchanger using using advanced software. For example, this model may be plotted by SolidWorks or AutoCAD or any other CAD program. Okay, and after that, okay, as you see, it is designed via SolidWorks. Okay, now after that, in the geometrical model, the author state what they planning to study. Okay, three different types of tubes. Let me show you. Okay, are the cross-sectional shape of the tubes. It is two of them elliptical and the third is circular. This is elliptical tube with 90 degree, but this is elliptical tube with 0 degree angle attack. Okay, so that three-dimensional uh, three-dimensional explanation will be give the image for the author for what the author want to explain. You can see here from this 2D photo, this is the elliptical inner body with 0 degree, but this is with 90 degree, and this is circular. They want to study the influence of these shapes on the heat transfer enhancement in terms of Nusselt number, as we will see. Okay, after that, since it is a heat exchanger, then of course we need two fluids, hot fluid and cold fluid, so that the author used the air and water fluid to investigate the heat transfer coefficient and pressure drop in shell and tube heat exchanger, so that the thermophysical properties is given here in the table 2. Okay, this is the size of the heat exchanger, shell diameter, and the units for each property. Okay, and after that, the authors give the another parameters that they use it even in the software in the numerical solution, which is the calculation of Reynolds number, because it is important as it helps us to know if the flow or if the fluid flow is laminar or turbulent. Okay, so that after that they transfer into the mathematical model. They use COMSOL multiphysics, which is a powerful tools on the heat transfer problem. The heat exchanger model, as I mentioned before, is plotted and designed via SolidWorks and simulated via COMSOL multiphysics. Of course, we need a boundary conditions and we need to explain the major differential equation, partial differential equation, which is, of course, as a mechanical thermal engineers, we know that the equations that govern the flow is Navier-Stokes equation. Okay, and since the flow is turbulent based on the value of Reynolds number, the author used turbulent flow of K epsilon turbulent flow. There is another types of turbulent model as we know. And now you can see that this is the question for turbulent kinetic energy and for dissipation, for turbulent viscosity. All of this equation is modeled in the COMSOL multiphysics, and all of these values is, as you can see here, which is actually the same value on the ANSYS Fluent, which is another software, powerful software on the solving heat transfer problem. Okay, it is actually some of the authors make a nomenclature table that illustrate each symbol, even in the Greek symbols. Okay, but the author um, present it in a different way. For example, you can see they don't use nomenclature, okay, which is normally or generally located here on the first page, okay. Some of the journals locate the nomenclature on the end of the paper, okay, but when you read the full paper, you will never find the nomenclature, so that the authors locate these symbols meaning within the text of the paper. Okay, now let us transfer on another important thing, which is the mesh control. Okay, you can see that they generate a mesh, which is the required points in order to solve the equation within this within this. Okay, number. Okay, and they illustrate that increasing the number of elements meant that the numerical solution will take more time, so that they make a mesh you can see here in order to take less number of element, okay, because you can see that increasing the number of element will need more time, so that they make mesh independent study in order to reduce the number of element and then reduce the number of numerical solution, but give acceptable and accurate result. Okay, this lecture actually will be useful and for any researcher in the field of the heat transfer, especially in the numerical heat transfer, because the numerical heat transfer need a software, need that you want to build the model, generate mesh, and solve the equations using powerful tools. You can see here that this is the number of mesh. Okay, this is actually a three-dimensional study, so that it is really good study. Of course, the numerical paper required verification and validation, so that the author make a comparison with another papers, which is experimental paper, in order to know the accuracy of their codes. And then the material and methods contain, of course, the calculations procedure for determination of heat transfer coefficient, the heat transfer in the cold and hot fluid, and you can see these are the nice and very pretty temperature contours, okay, lower limit and higher limit, as you can see here, temperature contour on the shell, on the tube, you can see here, okay, and of course the calculation of the logarithmic mean temperature difference is so important in the heat transfer um, paper on the heat exchanger specifically. Okay, this is the how to calculate the overall heat transfer coefficient, which is actually similar, very familiar even to the third year of the mechanical engineering student. And this is H sub I, which is heat transfer coefficient for the tube side, and D sub I mean inner diameter, D sub O outer diameter, and you can see that after and after you read the paper, you will find another result. For example, here you can see the inner circular body, here elliptical body with 0 degree, here elliptical body with 90 degree, but here I want to draw your attention that is this is circular, but this is elliptical body with 90 degree. Okay, this is elliptical body with 90 degree, but be on the center actually circular inner body. They try to study actually the influence of the shape on the heat transfer. Okay, and they give abbreviation which is looks so nice. Okay, so that it is important in writing the paper to select the abbreviation in a professional manner. And this is how to calculate the Nusselt number, because the Nusselt number is the indication of heat transfer enhancement. So that this is how to calculate the Nusselt number. And then when you read the paper, you will find the result, which is presented in a very professional manner. As you can see, this figure understands the heat transfer coefficient versus Reynolds number, which is ranging from 3,000 to very large values. You can see here that which one gives high heat transfer and which one gives lower heat transfer coefficient. You can see that the elliptical body with 0 degrees, okay, give lower heat transfer coefficient. Okay, let's take you back here, which is this. Sorry, this with the horizontal, the horizontal elliptical. A, which means that zero, okay, give lower heat transfer coefficient. Okay, so that when you read the paper, okay, you will find that the authors were in very nice manner, and they discussed the structure, okay, what the best type of energy to use. Of course, they place more too important on the internal flow, heat transfer, so that they consider calculations. Okay, you can see that the circular tube gives lower fixed flow. Okay, and the other result you can see. After that, the conclusion, I would like to draw your attention that null pulse percentage should be written on the introduction conclusions. Okay, some of the authors take points or paragraphs from the abstract and give it here, and this is not too small. Okay, and after that, the cited paper should be cited in a very professional manner. You can use Evernote or any other software for management of references. Okay, you can see that the cited paper actually cited from peer-reviewed journals, which is very important. For example, International Journal of Thermal Sciences, which is belong to the Elsevier, International Journal of Heat Mass Transfer, which is so high, and peer-reviewed journals belong to Elsevier as well. There is a Congress paper had been cited here. Okay, you can see that the applied thermal engineering paper has been cited. It is so good references on energy conversion and management, so that the authors write actually a very nice paper. It is important when you plan to work on the similar topics that you want to take some simulation on the heat exchanger is to study the related papers. And this paper, I recommend this paper for the researcher that interested on the heat exchangers. Okay, especially the authors focus on geometrical parameters, which is so important. I would like at the end of the lecture is to say thank you, and the next lecture will be uh, actually on another topics or another papers that we can study the paper and draw the major conclusion. Thank you very much.